Hey guys, Mr. Backerberg here. In this video we're going to look at remainder and factor theorems. Now one special case of the division algorithm occurs when you're dividing by a linear factor of the form x minus k. And that special case is called the remainder theorem. So if you're taking a polynomial f of x and dividing it by a linear x minus k, then the remainder from that division, your r value, is just f of k. So what that means for us is that we can find the remainder of a polynomial long division problem by just taking this k value and plugging it into our function and getting a result. So we can figure out the remainder without having to do any actual long division. So let's say we were looking at this example where we wanted to take f of x equals 3x squared plus 7x minus 20, and we want to divide it by x minus 2, but we want to figure out what its remainder is going to be. So then what we can do is, looking at this x minus 2, that would mean that our k value is 2. So if we want to find the remainder with this k value of 2, then all we need to do is take that and plug that into our function. So we're going to look at f of 2. So we're going to do 3 times 2 squared plus 7 times 2 minus 20. Well, 2 squared is 4, 4 times 3 is 12, 7 times 2 is 14, and then minus 20. And when we do all of that, we should just get 6 as our answer. So when we take 3x squared plus 7x minus 20 and divide it by x minus 2, then our answer will have a remainder of 6. Okay, same function here, but now we want to look at a different k value. So we're going to be taking this and dividing by x plus 1, which means that our k value would be negative 1. So if I want to figure out what my remainder is going to be, then all I'm going to look at is f of negative 1. So I plug in the negative 1. Negative 1 squared is 1, times 3 is 3. 7 times negative 1 is negative 7, and then we have our minus 20 on the back end. So that should give us negative 24 as our remainder. One more example in here. We're looking at dividing by x plus 4, so meaning that we're going to have a k value of negative 4. So we're going to look at f of negative 4. So when we take negative 4 and square it, we get 16, and if we multiply that by 3, we get 48. 7 times negative 4 is negative 28, and then our minus 20 on the back end. And when we combine all of that, we should get an answer of 0. So the remainder in this case is 0. And this is actually going to lead us into our next theorem. So if your remainder is 0, that means that your x minus k divides evenly into your polynomial function, which actually means that it's a factor of your original polynomial. So that gets us to this factor theorem, which says a polynomial f of x has a factor of x minus k if and only if the remainder, so that r value you get when you take f of k, is actually 0. So if you plug in that k value and get 0 as your answer, that means that the original x minus k that you started with is a factor of your big long polynomial, and it will divide evenly into that big polynomial. So we're going to take a look at using that factor theorem real quick, and we're going to do some long division in here. And I'm going to take that 3x squared plus 7x minus 20, and I'm going to divide it by x plus 4. Now, based on what we did earlier using that remainder theorem, I already know that I'm going to get a remainder of 0 at the end, which means that this x plus 4 is going to be a nice factor of our polynomial that's underneath the division bracket. So we're going to run through and do our long division to figure out what the other factor would have to look like. So we're going to look at the first terms in here. So we got the 3x squared and the x. So if I take 3x squared and divide it by x, then one of those x's on top will cancel out with that x on bottom, so I get just 3x. And then if I distribute my 3x times x is 3x squared, and 3x times 4 is plus 12x. And I'm going to subtract that stuff from our original polynomial. So the 3x squareds cancel out when we subtract. And if I take 7x minus 12x, I'm going to get negative 5x. But I still need to drop down this minus 20. Now if I look at my first terms again, I've got the negative 5x and the x. So if I take negative 5x divided by x, then those x's are going to cancel out, and I'm just going to get minus 5. Distributing the negative 5 times x is negative 5x, and negative 5 times 4 is negative 20. Now when we subtract this stuff, we should notice that everything is going to cancel out. Negative 5x minus negative 5x cancels, and negative 20 minus negative 20 cancels. So we get that remainder of 0. And our answer, the quotient, is this 3x minus 5. Now what this means, using that original divisor of x plus 4 and this 3x minus 5, our quadratic that we started with, that 3x squared plus 7x minus 20, will actually factor into x plus 4 and 3x minus 5. So if we're taking a look at a polynomial function f and some real number k, then the following 4 statements are all equivalent. So saying that x equals k is a solution or a root of the equation f of x equals 0 is the same as saying that k is a 0 of the function f, which is the same as saying that k is an x-intercept of the graph of our function y equals f of x, which also means that x minus k is a factor of your function f. So basically all of these things are saying pretty much the same thing, just in a little bit of a different way. That's going to be it for this video. Thanks for watching.